Hey everyone, just wanted to take a quick minute to walk you through the manufacturing lab. Since it might be a little bit before you get in here, let's just get you kind of warmed up and understanding the layout. When you first walk in, we've got our CAD lab with all of our computers set up here. Eventually, hopefully after all of this, you'll get a chance to come in. Over here, we've got a couple of CNC control simulators from Haas CNC tools. When you walk in here, this is where really all the fun and awesome happens. So this is the manufacturing lab. We're split off into two sections. We've got the right side of the room, left side of the room, center of the room that you'll notice are split by these yellow safety lines. When you come in here, you will learn how to operate the majority of the equipment on the right side of the room during your first semester. You'll move on to the left side of the room during second semester. Right side is learning about 3D printing, design, some manual machining. Over here we start learning CNC equipment, computer controlled, and advanced automation. So let's walk around. Over here is the electrical AC/DC circuit workbench. This is where we will start working on all of our embedded science credit, our AC/DC stuff. It also has one of our main projects sitting out that you'll learn more about. This is the 3D printer farm. Right now everything's shut down, but this is 6 different large volume 3D printers. The students last year built this entire assembly. This whole thing is their project from last year. It has integrated webcams, it has LED lights. This was used during the summer at the very beginning of the COVID pandemic to provide PPE and ear strain reliefs to medical workers and other essential workers in the very beginning during March and April. A lot of this was remotely controlled by the students. So you will have access to this on a remote basis. We will actually make real parts that you design from home here, and we'll go through our testing. So in this workspace here, we've got one of our new machines that we're still excited about getting connected. This is our GCC CO2 laser. We haven't had a chance to get it used yet. It literally just came in. You'll see 2 knockouts on the wall that are set up for us to get it powered up. I can't wait to have that up and running. You guys are gonna make some really cool stuff with that. Moving down here, we've got our manual machining section. This is a knee mill, but really it's kind of a mill drill. I stutter because you're going to learn the difference between this from a normal drill press that you might have seen in some of your garages and a Bridgeport full knee mill that you'll see in proper machine shops. This is kind of in between, so it's a little bit of the best of both worlds. And then we have 2 small desktop manual lathes. The only difference between these 2 machines, they're both designed to cut all types of materials. On this one, the material sits still and the tool spins. On this one, the material spins, the tool sits still. This is mostly for our round items. Something like this. This would be something we would do on the lathe. This is for a lot more of our square and blocked off pieces. You'll notice there's all kinds of stuff built right here, which makes it look kind of like a mess, but this is part of the field elements for this last year's first robotics competition. The students last year built all of this. So when it's time for us to do a scrimmage between other teams in the county, we will actually move all these tables out of the way, set this up in the middle of the room, and the other schools will bring their team robots in to test. Right here, you'll see we've got 2 of our arcade machines, our full-size 2-player arcade machines, which are pretty awesome. These were designed by our students 2 years ago. They were further perfected by our students last year, and hopefully by second semester, you will have a chance to make this even better. There's constant upgrades that need to be done and can be done. This time around, you'll notice one of our upgrades was the controls. So normally you see buttons 1, 2, 3, 1, 2, 3. This one, we actually set this up to match your hand. This one's just for 3 button. And this one over here is set up for 4. So when you lay your hand down naturally, everything sits where it is. These are pretty fun machines, so it's pretty neat to make these. These are completely designed by the students, completely built by the students. This is something that you will have an opportunity to be a part of. Hidden behind these, this was this last year's design. They decided to come up with, it seemed more of a 90s Tekken style layout. I'm not sure I'm a huge fan of it, but that's part of learning how design works. You'll have to let me know in your comments and in discussions, which ones do you like better? I'm kind of the retro guy myself. Over here are our two large CNC machines. This is a CNC mill. This is from Haas Machine Tool. This is a mini mill. Right here, you'll see this is a tool holder. Let me put this back. This is our tool holder. These are the types of tools that you would see in a CNC machine. This is a large drill, and each one of them have this exact same type of collet connection that gets drawn into the inside of the machine. All these different types of tools do cutting and shaping, mostly of metals. We won't be doing much more other than metals inside of here. This is the inside of the machine. It's a vise that holds our material. This is a tool carousel that holds all of our tools. This is a probe, and this is the actual spindle, the piece that does all the work. You will have an opportunity to learn how to use this controller right here. I know that seems like a lot, and it looks crazy, but trust me, it's not as intimidating as it appears, and you will figure out how to do it. As a matter of fact, while we're standing here, let's get it started. Door is open. We're gonna close the door and power it up. Right now it's doing what's called zeroing out. The machine is figuring out where the outside edge of the table, which is this portion right here, and the outside edge of the spindle. So if you remember geometry from middle school, high school, that's pretty cool, isn't it? So there you can see it actually got a tool, and here it is inside the spindle. What I was saying was, if you remember from middle school and high school, this machine operates on a Cartesian plane. We've got the y-axis, the x-axis, the z-axis. The spindle is our z. The table here does our x and moves in our y. A combination of moving from point to point in x, y, and z allow this tool and this machine to manipulate and shape metal of all different shapes and sizes. Right now we're going to turn on the warming up cycle. It's something we have to do regularly to make sure that the bearings and the lubrication in the machine keeps moving. Also, we're going to turn on the coolant. This machine uses a type of flood coolant. You're going to learn all of this stuff, and it's all pretty neat. Over here is our Haas TL1 lathe. This stands for Tool Room 1 lathe. We're going to come over here and twist our e-stop and power it up. I'm going to open these doors and show you what's inside. So just like I just showed you on the other side, this is a CNC or computer numeric controlled version of the machine over there. There's a computer on this machine, computer on this machine, and once these doors are closed and the program is loaded, everything is fully automated. This is pretty cool. Here we have a horizontal bandsaw. Horizontal bandsaw sounds just like it is. It's a bandsaw. It's a saw blade that, if you can see it, it's right here, follows all the way around in there on a large band. Once that's activated, the saw turns. This is designed to come chopping down. This one is a vertical bandsaw. Also, same way, you'll see that there's a band that goes all the way through here. And because this one's standing vertical, it's considered a vertical bandsaw. We've also got a miter saw for when we do woodwork, which we actually did a whole bunch of for building the first robotics pieces. And then right here, you'll see we've got our Cam Master Panther CNC router table. So this is a 4x8 CNC router system. And what that is this is essentially a large scale wood cutting version of those two machines, what they do for metal. We can take an entire sheet of wood from Home Depot, place it on here, and cut almost anything out of it. Great example, the arcade machines. The arcade machines were fully designed in 3D CAD software, and every piece was placed like a puzzle onto multiple sheets of wood, and that router cut them out following the profiles designed. You'll see we've got quite a few stacks of wood left over here. So we have quite the opportunity to make a bunch of pieces. This one that's laying on here right now is called a spoil board. Again, all these things you're going to learn. The spoil board is designed to actually suck down, using the vacuum, wood down to the table so that we don't have to clamp it, we don't have to glue it or screw it. It's actually suctioned down, held in place, and that's how we cut stuff. If you guys know your maps, that's actually a map of Gwinnett County that we did this last year. Each of these sections are school clusters. I think we're this one. And if you look real close, you can see that it's different layers. And then we cut them all at different heights to create that depth. It's pretty neat. We get to the front over here, and this is where the controller for the CNC is. The router here uses a system similar to the CNC mill. It's got a tool changer right there, and you'll notice they're just smaller versions of what I just showed you. And here's the spindle that holds the cutter. So these both work in very similar fashions. They're just very large pieces of equipment. All of these pieces on this side of the room are industry relevant, true industrial CNC machines. These are actual machines that you would see in the field if you got a job as a manufacturing professional, a machinist, a manufacturing engineer. These are where some of the coolest things, I think, in the county are made, is right here.